I'm Olivia Dale, and I'll be talking about my project, which is an investigation of white mica argon-argon geochronology and geochemistry of basement shear zones on Folegandros in the Cyclades in Greece. The island of Folegandros is located in the southwestern Cyclades within the Aegean Sea. Here with my pointer. The region as a whole has experienced a collisional event when the African plate collided with the Eurasian plate during the Eocene. This led to high-pressure metamorphic conditions and subduction. Subsequently, during the Miocene, the African plate began to retreat, which caused an extensional regime and therefore the exhumation of those high-pressure rocks. These two deformational events gave rise to regional scale network of faults, as seen up here, as well as three distinct shear zones that span the island of Folegandros, seen down here. The objective of this project is to investigate and interpret the timing and conditions of deformation within the shear zones on the island of Folegandros, such that this may be used to relate to the previously studied regional deformational events. To investigate these shear zones, field observations and samples were taken both inside and outside of the shear zones. Petrography was used to classify samples and determine metamorphic assemblage as well as grade, and argon-argon dating was used to determine the ages of the white mica within these samples. To properly interpret these ages, however, a geochemical analysis was performed on additional white micas using electron microprobe analysis. This allows us to relate the ages found from the argon-argon dating to the white mica geochemistry. In general, the ages obtained from the argon-argon geochronology range from 38 to 20 million years. The geochemical analysis shows a very low pyrophyllite concentration in all samples and a dominantly muscovite concentration in general, but particularly within the samples found in the shear zone. These samples in the shear zone were also seen to be generally younger than those taken outside of the shear zones. By contrast, we see that the samples with the highest white mica ages also have high salatinite concentration, which is the high pressure phase of white mica, and they are located outside of the shear zones. Additionally, the higher pressure mineral assemblages are preserved in a few samples taken outside of the shear zones, whereas green schist facies were seen in all shear zone samples. To conclude, Eocene ages were found in samples with high salatinite concentration and higher grade mineral assemblages, which indicates the preservation of high pressure conditions caused by the Eocene compressional event. Conversely, the shear zones themselves show Miocene ages and have a high muscovite concentration, as well as mineral assemblages within the green schist facies. All of this suggests that the Eocene collisional event is preserved on the island of Folegandros, and the shear zones were activated within the Miocene extensional event and overprinted those high pressure rocks with the lower green schist conditions. Thank you.